Algebraic expressions. So as you can see here, we have evaluate 2x minus 8 for x equals negative 2. So here's our x, and they're telling you what x equals. So what we're going to want to do is we're going to want to plug in that negative 2 for that x. It's important that when you're plugging in, you put parentheses around that variable. So for example, let's put empty parentheses where our variable x would have been. And now we're going to plug in that negative 2. So look like this. 2 times negative 2 minus 8. Now according to the order of operations, we know that we have to multiply first. And we get negative 4, bring down the minus 8. And then negative 4 minus 8 gives us our final answer of negative 12. Take a look at the second one. We have 8 minus b. So here we have b, and they're telling us that b equals negative 6. So we're going to plug in for that b. Again, it's very important to put empty parentheses where that variable was. So 8 minus empty parentheses, and then we're plugging in that negative 6. Here it was really important because if we take a look, a lot of us may forget that it was going to be a minus and then a negative next to each other, which changes our answer because we know that 8 minus negative 6 turns to a giant positive, and then you get an answer of 14. Okay, 4a minus 3b for a equals 5 and b equals 2. Here we have two different algebraic, two variables. So we have a when it equals 5, and we have b when it equals 2. So we're going to have to plug in both of those, which means we're going to have two sets of empty parentheses. So in the parentheses, we plug in 5 for a and 2 for b. According to the order of operations, we have to do multiplication first. So 4 times 5 is 20, 3 times 2 is 6. We get 20 minus 6, which equals 14. Next one. We have f equals negative 9, and we have y equals 2. So if we go ahead and plug those in our parentheses, we have negative 9 minus 10 times 2. Again, according to the order of operations, we have to do 10 times 2 first. We get 20. Bring down what's left over, the negative 9 and the minus. And negative 9 minus 20 gives you negative 29. Now this is something a little bit different because this one is within a fraction. They tell us that we have two b's that equal negative 4. So these ones you want to work a little bit differently. You want to work from left to right. So if you take a look, we plug in our b for negative 4, and it looks just like this. And now let's solve just the numerator across and just the denominator across. So we know, according to the order of operations, we'd have to do 2 times negative 4 first, and then we'd also have to do the 3 times negative 4 first for the denominator. We get negative 8 minus 5, and then on the bottom we get negative 12 minus 1. Now we can continue solving the numerator. Negative 8 minus 5 is negative 13, and negative 12 minus 1 is also negative 13. And lastly, we know that negative 13 divided by negative 13 equals 1. Take a look at number 6. X squared minus 2x plus 5, where x equals negative 10. So let's plug in for that x. We have two of them, and it's negative 10. We're going to plug in here, and we're going to plug in here. Again, parentheses are very important here because we know that negative 10 squared is completely different than negative 10 in parentheses squared. So that's why parentheses are very important here. Alright, so let's take a look at what it will look like when we plug in. Negative 10 squared in parentheses minus 2 times negative 10 plus 5. Now, according to the order of operations, we have to perform exponents first. So negative 10 times negative 10 is the expanded form of this here, and we get 100. Bring down what's left over. Next, we have to do 2 times negative 10, which equals 20. Bring down the 100, bring down the 5, and then 100 plus 20 is 120, and then 120 plus 5 gives us a final answer of 125. Okay. Now we can also evaluate algebraic expressions in word problems. So let's take a look at number 7. A store sells one model of a bicycle for $250. Write an expression for the amount of money the store receives if it sells B bicycles. So we don't know how many bicycles they're selling, but if each bicycle costs $250, we would multiply to figure out how many they're going to sell as an expression. So $250 times the amount of bicycles, which we don't know, would give you your answer for the amount of money the store would receive. So evaluate your expression for 5 bicycles. Now, they told us to use B in our expression. And here they're telling us how many bicycles we have. That is our B. So B equals 5. So I'm going to take that and plug it into my expression 250 times B, which would be 250 times 5, which would give us an answer of $1,250. Make sure you include your units, it's very important here. Last one. An amusement park charges $5 for admission and $2 for each ride. Write an expression for the cost of the admission and our rides. So the amusement park, just to get in, seems to be charging you $5. Then we have that keyword and. If we remember, and indicates addition. Then we have $2 for each ride. Each is that keyword also that indicates multiplication. And then we have rides. Write an expression for the cost of admission and rides. Our rides. So they told us that rides have to be represented by R. So let's take a look exactly what we have here. We have the admission plus the cost per ride. I know that we have admission and it's $2 per ride, which therefore means admission's $5 plus, which we add from the and, 2 times, which is our each, R rides. So our expression would be 5 plus 2R. How much would it cost if you go on 16 rides? So they told us that rides was indicated by R. So R equals 16 from this part. So all I have to do is evaluate. Plug in 16 for R. 5 plus 2R, which would be 5 plus 2 times 16. And then I would get 5 plus 32, which is a total of $37. Again, important to incorporate that unit of measure, that it's money. And that is it.